I'll be back in just a moment. I'll let people fill in. I'll be back in just a moment. Hello, everybody. How are you this morning?
Fine, Doc.
Great.
Mine as well.
Great. I'm glad you all could be here. I want to start out first with if you haven't got access to Moodle yet or a Claflin ID, please put it in the chat so I can follow up with it after class today, because we want to make sure you all get in. So please do that. So I always like to start, often it's with a quiz, but today we can just talk about it. I like to start with talking about what we talked about last time. So last time we talked about the scientific process in peer-reviewed journals and the process of peer review and writing scientific assessments. So my question to you is, can you explain why is it more trustworthy to believe a peer-reviewed journal article versus another article you might read in a newspaper or somewhere on the internet, and why is that true?
Peer review articles typically go through a sequence of checks and balances in a sense. So after, of course, being read by other researchers, kind of in the same broader scope of the field, it would then have to be tested by a set of researchers after that point, versus a newspaper article where it's really just, for lack of better words, banter or maybe propaganda that hasn't been sent through any checks and balances, maybe just through an editorial space. And that's why it's a lot better to trust peer-reviewed scholarly articles as opposed to newspaper articles that you would probably find on the phone.
Okay. Can anyone add to that? So specifically, what's the custom in terms of if you send in a scientific paper to a journal, how many reviewers do they usually send it out to? How many scientists do they generally send it out to?
Is 3 if I'm not mistaken.
Correct. Yeah, 3. So it'll go out to 3. They'll have a few weeks, about a month, to go ahead and review it. They don't usually retest experiments, but they go through and they'll look at the experiment, how it was set up, make sure that the proper controls were there, that they don't see any obvious flaws with, how the experiment was set up. They'll look at the data. They'll see if the conclusions that you draw from the data kind of match what the data has to say. Sometimes people like to overinterpret. They'll also look to see if the data makes sense based on what they know about the science. And they'll also look a lot at your reasoning. So when you send in a paper, you usually have a big introduction that talks about the topic, that introduces the science and talks about the reasoning behind your experiment and how you're kind of interpreting the literature up to the point of the experiment. So all those things they look at in detail. They'll look at your references to make sure they're up to date and the most current stuff. And if they've got any problems with it, they'll write back to the journal, and then the journal will send those issues back to the author to see if they can correct them. If it's something that the reviewers felt, could be addressed by, rewording something or answering certain specific questions, etc. And so that's what gets it into the journal to get published. Okay. It also has to be something that's relevant. In other words, it can't be research that's already been done before. It has to be a new finding, unless you're trying to test the reproducibility of some previous experiments. And that's really only publishable if you find that they weren't reproducible. So there's always this big drive or impetus to be able to disprove what other people said. And so that gets it into the literature. Then what occurs is kind of what I like to call, and what the author likes to call, the crucible of science. It sits there in the literature, and then lots of scientists read it. And if it doesn't make sense to them or they object to it, they may test your conclusions. They might rerun the experiment, or they might run parallel experiments that kind of test the same hypothesis to see if their results match your results. And if they don't, that's publishable. Because now you're saying, okay, I found something that disagrees with something in the literature. So that makes it publishable, even though those similar experiments have been done before. And so there's always this drive to filter through what's out in the literature and winnow out anything that's incorrect. And so if something sticks in the literature without being disproven for a long period of time, especially if, you know, there's a lot of attention on that particular topic, you can be fairly certain that it's really based on good science and it's something that's really believable. So what is a scientific assessment? We talked a little bit about that last time as well. Okay, I hear silence. Okay, fair enough. It's probably good to take notes, you know, as you're doing these lectures. What I'm going to be doing, you know, is having a quiz at the beginning of each class, asking you about specifics about what we talked last time. So it's usually helpful if before class you start taking a look at, you know, at your notes and see what we talked about last time. Maybe go through the PowerPoint. And I will make sure to, let me go ahead and do this now so I don't forget. I'll make sure to attach the PowerPoint from last time as well as this time, so you can go over those PowerPoints for those of you who don't have access to Moodle yet. So back to scientific assessments. Those are generally written for lay people who aren't scientists, and they're basically a summary of the science, usually done by a scientist who's pretty good at speaking like normal. And you know, often those are produced for policymakers, people who make laws, people who have to make decisions based off the science, but aren't scientists themselves. Any questions on that? The reason I'm going over this oh, go ahead.
Sorry, more explanation on that. I didn't get you properly. The scientific assessment.
Oh, so a scientific assessment is when a scientist will summarize what's in a scientific paper or several papers. They'll summarize the science for a lay audience, for people who aren't scientists. So it could be for lawmakers, it could be for politicians, it could be for people that work, you know, in the Department of Natural Sciences or the DoD. They might not be scientists, but they need to make decisions that are based on the science. And so it kind of explains it and, you know, without the scientific jargon. So it's easily understood. And usually those scientific assessments, those are peer reviewed as well. So it's sent out to another scientist who then reviews what's said to make sure that there's a good check and balance, that how the person is summarizing it isn't really biased towards one idea or another. The reason I'm spending so much time on the scientific process is, you know, when you're out in the world trying to do climate action and trying to, you know, make these proposals to fight climate change, you may run into folks who are anti-science or who just, you know, really don't understand what to believe. They're reading things off the internet, etc. And so you really have, it really helps to have a good understanding of, you know, why you believe what you believe in the first place. And that brings us to the subject of today's lecture, which is going to be on the International Panel for Climate Change's report, their summary report that they give to lawmakers and how that was produced, because that's considered the definitive, categorical statement of the science currently as it stands on climate change. And we're going to be going back and forth to that document throughout the course. And you'll see it again when you do the environmental policy and management course as well. And probably when you, at some parts in the research ethics course. So again, ask questions as we go along. If you've got any, feel free to. If you've got a question, probably a bunch of other people do, just interrupt me, and that's totally cool. Okay, so let's see. Nope, that's not what I want to stop sharing. Why is that not sharing right? Back to here, push screen. There we go. Okay, here we go. So we're going to talk about scientific assessments and the IPCC. And from this lecture, my hope is you'll be able to describe the writing and evaluation process for the IPCC climate assessment, be able to explain why or why not it can be trusted, and compare that to some competing climate assessments, namely the NIPCC, which was put out shortly afterwards, kind of as a counterweight to the IPCC. So what is the IPCC? It's the Intergovernmental Panel on Climate Change. And they've been writing assessments about climate change since 1990. In 2007, they won the Nobel Prize for their action in the area of climate change and the climate crisis. And I have a link on our in the PowerPoint that takes you to the latest assessment, which came out in 2023. It's called the 6th assessment. And again, we're going to be referring back to that. It's a really interesting read. It'll give you an idea really kind of where we are in the totality of climate science. But it's really important to understand how it was produced, because it says a lot of stuff, and some of it you might be like, do I believe that? Do I not believe that? You know, how much confidence can we have in these things? And so it's really important to think about the process. Just like when you look at papers that are in the peer-reviewed literature, you can have more confidence in what they have to say than something just off the internet. And so it's really the process that kind of determines how trustworthy something is. You know, what was going on in the kitchen when they were making the food, right? And so we're going to try and pull back the curtain a little bit. And so the first step is really about how they selected the writing team. And remember, this is the International Panel on Climate Change. There's over 200 countries that are involved in producing these documents. So step one is selecting the writing team. And each of these different countries are going to be nominating somebody to be on the writing team. So remember, there's over 200 countries, around 202, I believe, in the 2023 assessment. 202 countries nominated scientists to be on the writing team. And so the membership of the writing team is spread around all the countries in the world. And each country gets to select their own scientist, and there'll be literally hundreds of scientists on the writing team. And, you know, one of the arguments about why what they might produce might be believable is because of bias. So if there are many countries involved, no single country is getting to control the message or getting to get out there what any specific idea or bias that they want, whether they believe in climate change or not believe in climate change. And because hundreds of scientists are involved, it's not biased in any one particular scientist's point of view. And so you've got a lot of them working together. In order for it to be biased, you'd have to have 200 scientists that were all picked that all have to be biased on this. And that's really very unlikely, considering that different countries have very different interests and different concerns. And they're affected by climate change in different ways, some of them a lot, some of them not so much. Some of them benefit from fossil fuels and the sale of fossil fuels, others don't. And so there's a wide variety of interests playing a role in these countries when they're selecting their scientists. And so it's unlikely that all the scientists would be of a particular ilk. Okay. So after they put together the writing team, those scientists will assemble, they'll look at the science, they're each experts in their field. There might be an expert in atmospheric science, there might be an expert in oceanic science, and experts on glacial melting, experts on physical chemistry and atmospheric chemistry. wide range of different individuals, and usually a country, because of the prestige of being on this panel, they'll select and nominate the top scientists in their field in their countries. So they sit around and they talk about, what should we say about climate change? What do we really know? And it can actually take several months for them to start to come up with the framework of what they want to say is actually going on with the Earth's climate and why we should believe it. And they're reading the peer-reviewed literature, and they're making statements that are based on peer-reviewed experiments. Every single one of them will have a citation. So if you've ever had to write a thesis or a lit review for any statement that you make that isn't just common sense, you need to have a citation that refers to the primary literature that's been peer reviewed to say, okay, this is a fact. And so they'll put together this large report on the state of climate change. But that's not all. There's a second step, and that's the scientific and public review step. So the report itself is now sent for peer review to other experts that aren't on the writing team. And there could be up to 100, 150 other scientists that this report is sent to, that are now examining what's said. Does it match the science that they're aware of in the literature? And since they're experts in the field, does it match, what they're seeing? So it's reviewed for accuracy by these experts. And then there's also a public review. So it's posted on the internet, and they invite comments. In the last climate assessment, there were over 50,000 comments. Each one had to be responded to and addressed before they could move on to the next step. And so, as you can imagine, it's a months-long process, takes a long time to do, but it's now taking input, not just from the writing team, but now from scientists, from regular people who are writing in and saying, I don't believe this, or what about this, or what about that? And so all of that has to be responded to before they go on to the next step, which is now writing that's, well, we'll get to that. So that's step 2. Step 3 now is the government review. Oh, okay, I'm sorry. Let's see, I got this a little bit screwed up here. Yeah, here we go. So I'm sorry, actually, I have these misnumbered. So step 3 should be the creation of the SPM, or the summary for policymakers. That's the assessment. So the original document is all the scientific jargon, all the scientific findings, all the conclusions that these scientists have written that they believe, and they all had to agree with it. Then they've sent it out for review. Comments had to respond to the reviewers' comments and to the comments sent in by the open forum, by the public comments. And now, after they've done all that and rewritten their scientific report, now they have to write the summary for policymakers. That's the same thing like we talked about before, is a scientific assessment. It's written in more general terms so other people can understand it that aren't scientists. And it's essentially a summary of all the scientific findings in lay terms. And it also includes the recommendations that the scientists have based on all of the data and all the experiments that they're reviewing. They have recommendations on what should be done next. What steps do we have to take? So they write this assessment, the summary, and the process doesn't stop there. Now step 4 is our government review process. So once that SPM, or summary for policymakers, is written, then each government gets a copy and they get to review it line by line, and they get to accept or reject each line. So they vote on every single line. And the final agreed upon document only has statements that all of the countries have unanimously agreed upon, which takes a lot of work. And there's a lot of haggling, a lot of discussion. But the idea is by only having statements that all the countries can agree upon, later on, when they're talking about, well, we're trying to do these recommendations, they can't just say, oh, well, we didn't believe in that particular conclusion, the assessment. No, you voted on it. All the countries voted on it. This is what you agreed to previously. So what do you think about this process? Now you've heard about it. What do you think about it?
It seems kind of lengthy and drawn out, but
Very
but I
much
think
so.
but I think it's the best way to go about, of course, the inception of new policies and new ideas for, you know, and the I think the process is put in such a way because when you start adding a dollar amount to ways to reduce climate change, people want like throw ideas and concepts that have been sent through a ringer, such as this one. When you start talking about allocating trillions of dollars to this effort, or maybe billions of dollars to this effort.
Exactly. Exactly. And you really want to have a strong leg to stand on, saying, well, 200 scientists, 200 diverse countries all agreed on this. So there's got to be something, there. Now in the chat, I'm going to go ahead and paste in, that's the link to the IPCC. And so what I would recommend, click on it when your browser opens, bookmark that page so you can go back to the IPCC. It's going to look something like, let me shrink this down so you can see it all. It's going to look something like this. And to find the reports, if you go to the report, the latest report is this AR6. This is the assessment report 6. You can find out about who the core writing time is. You can also read the reports. There's included in there is the summary for policymakers, the actual longer report. Here are some statements for like newspapers and headline statements. Here are many of the diagrams that are used in there and that can be used. And then a link to the presentation made during the press conference, the press release. And again, they'll go through all of these different, the process that we just talked about to kind of justify, what this is. But I strongly suggest checking out this website. There's also a lot of, you can read about their activities and how the organization works. And who knows, one day you may be a member of the IPCC. Especially they have working groups, and I believe there's a working group on biotechnology. That might be a goal one day to be part of that working group to help propose solutions that might deal with climate change. So that's the IPCC. But there's this other thing called the NIPCC, which is the Non-Governmental International Panel on Climate Change. They also produce a very long report. And what's interesting is they almost find exactly the opposite in their report. Climate change isn't due to fossil fuels. The weather really isn't changing. The temperature isn't changing. The ice really isn't melting. We're actually experiencing a cooling period, not a warming period. And so they have, pretty much taken the opposite stance on every single one of their conclusions. So how would you know which one to trust? If somebody brings you, their NIPCC report and says, well, look at what this says. Climate change isn't happening. Fossil fuels are fine. What would be your argument, or what would you go to if you wanted to say, well, I don't know if I trust that.
Would it be to go to the IPCC?
Well, they could say, well, what's the difference? This is the non-governmental one. That's the governmental one. What's the difference?
Not really sure.
Okay. What is it that gives you confidence in the IPCC conclusions? I mean, are you likely to believe stuff in the IPCC, or based on my presentation here, are you still like, who knows what they say?
I personally would go with the IPCC because it tallies with the changes that I am personally seeing and I can attest to, even though I don't have like scripts that I can support myself, but it's evident that like the planet has signs that are showing that this thing is happening. I also would question the motive of the NIPCC because a part of me feels like it's a group of individuals who did this to counter the IPCC because of their motives. Like, what would be the motives? Probably these are the biggest like players in the industry of fossil fuels. They could do something like that so that they can support themselves.
So, Desire, I think you hit the nail on the head in your answer. You eventually circled back beyond the anecdotal stuff of what you see, which is important, but you could be in a country that isn't seeing many climate change effects, or a part of a country that really you're not noticing it because you don't watch the news. But you hit the nail on the head when you went back to, well, who wrote it? How was it written? Who are these people? Are they biased? And so that brings us back to that original thing that I had said earlier, was that the process probably tells us how trustworthy the result is likely to be. So if one looks at the process behind the NIPCC, I've got a little comparison graph here. For the IPCC, the writing team was assembled from nominations from 200 member countries. For the NIPCC, what they state in the report is that the lead author recruited chapter lead authors. I'm sorry, this is supposed to be the lead author. Recruited chapter lead authors, and with them coordinated the organization and development of the individual chapters. So they picked one person, and then that one person recruited and picked the lead authors for all the other individual chapters. So if that one person is biased, then all the people that they pick, what's to say that they're not biased? They're selecting people that agree with the opinion that they're trying to espouse. And the IPCC, you had many different member countries picking these folks. In the NIPCC, you got one lead author. Who is he? What's his background? Why is he doing this? Great questions to ask, but just from the outset, the fact that one person is in charge of the whole thing may lend you to feel it may not have as much credibility. Second part is in the IPCC, we had open peer review. For the peer review for the NIPCC, it states in their explanation that chapter reviewers will be nominated by the lead author and the chapter lead author. So the people that wrote it get to pick the people that are reviewing it. Okay. And then as far as I could tell from the research I've done, that's pretty much it. That's their review process. I didn't see anything about an open peer review or comments or anything like that they have to address. And lastly, in the IPCC, once everything was written, each of those 200 member countries got to go through and vote line by line on different statements in the assessment. That isn't true on the NIPCC. They just publish it and say, here's the proof global warming isn't real. And so, again, I bring this up because it's very possible that when you're arguing for your proposal to make a change in a particular region, that somebody is going to bring out, oh, well, here's the NIPCC. Sounds a lot like the IPCC, and look at these conclusions. Now you're armed with a little bit of information where you can, talk to a reasonable person and say, look at the process that created this thing versus the process, that I'm relying on, et cetera. And I hope all of us will rely on the IPCC versus the NIPCC. So really, not all assessments are equal. You have to trust assessments that have a credible process. Now, if they have a credible process and they come up with conclusions that you don't agree with, as scientists, you still have to consider those ideas. You have to work through them, and you've got to have an open mind. If the process is credible, they're seeing something that needs to be addressed, and that's how science works. A lot of times you find facts or observations that might be counter to a prevailing theory, and you've got to make those changes. So be aware and always ask yourself, what was the process behind the thing that I'm reading now? If it's a peer-reviewed article, it's gone through the peer review process. If it's a news article, it's got a news editor, which there are a lot of organizations that have very unbiased, objective news editors. And then there are a lot of news organizations that don't, right? And so then you kind of have to pick and choose and take it with a grain of salt or think about it. But the IPCC isn't the only assessment on climate change. A bunch of other groups have also done their own assessments, from the National Academy of Sciences in the US to the UK Royal Society, NASA, NOAA, NSF, other scientific organizations like the American Meteorological Society or the Geophysical Union. And there's identical counterparts in just about every other country that's facing any kind of climate change, that have similar organizations with scientists that have been making similar assessments. And 99.99% of the published assessments from these credible organizations are in agreement about the facts of climate change. And for our course, this course is going to rely entirely on peer-reviewed science, stuff in the IPCC, and things that have gone through a very credible process of peer review. So this way, no one can come back to you later and say, well, the facts that you're citing or the thinking that you're citing in your proposal isn't based on hard science. We're going to try and keep everything to be based on hard science. Any questions on this? I know you guys are eager to get to the climate science. We're getting there. I just need to set the foundation. Okay. A lot of this is pretty esoteric and theoretical. Talking about this way. What I'd like to just briefly go over one real world example that might hit home. And that's the scientific process when COVID hit. Okay, we all remember COVID-19 and how it spread through the world like wildfire and created a worldwide pandemic. I know you probably all have had personal experiences with how you've had to deal with the pandemic. I'm actually interested in hearing about them because I think they shape our experiences towards other things. And it's related to climate change because as the climate gets warmer, we expect more and more epidemics of a variety of different diseases. So, in my lifetime, this was the first pandemic. Same thing in my parents' lifetime. My mom's 87 years old. This is probably not the last one that will occur in your lifetime, unfortunately. So it's good to go over this as an example. And it's true that real world events sometimes can outpace the pace of science. You know, it takes a long time for a scientific consensus to be reached. People do experiments, they write the papers, experiments take a while, it takes a little while to write the paper, they send it to a journal, the journal sends it out for peer review, that could take weeks or months, comes back and they publish it. Now it's got to sit in the crucible of science. Can that publication withstand all these other scientists testing and stuff? That takes a long time. Could be years. Okay. And COVID was a new virus spreading in a new way, and people needed scientific answers way faster than science could provide. And so I don't know if any of you remember, but in the beginning of 2020, this was in February, the US's own Surgeon General said, stop buying masks. We don't need masks. They're not effective in preventing the transmission of COVID. It was the first thing we said out of our government. So that was early on. The science hadn't yet caught up. We hadn't yet discovered that it's transmitted by aerosolized particles. It took a few months for scientists to make that determination. And then lo and behold, a few months later, CDC comes out with a new guidance that now for the remainder of the year, everybody should wear masks. So over time, science evolves with their recommendations, right? The fact that the information on masks was incorrect at first isn't necessarily a reason to doubt the scientific process, because we know it takes time, right? And I think we generally know that that's true. If scientists review their conclusions and change them over time, that's actually a reason to trust them. So think about it. If you went into the doctor and you were really sick and they took a look at you, ran a couple tests, and they say, you've got this bad bacterial infection, please take this antibiotic for the next 3 days, you should get better. You're not going to turn around at them and then say, well, wait a second. In the Middle Ages, you doctors used to say that being sick was caused by evil spirits. So now I'm supposed to trust you on taking antibiotics? That doesn't really make sense. We know over time, our understanding improves. But yet at the same time, it was a real problem because scientists were saying one thing, then a few weeks later, they were saying something else. And so do you think you should still, like when something new comes out, should you trust what experts have to say?
I think you kind of have to. You're putting it's between a rock and a hard place. I think you kind of have to because you have really no other option, essentially.
So I'm interested to hear each of your perspectives on this, actually, because you remember what it was like when it first came out and you started hearing some information and then different information. What did you feel? What was your feeling towards expert advice and trying to figure out who was saying what? Some people were saying, oh, you should take ivermectin or hydroxychloroquine and that'll cure you, and all these different things. What was your personal experience and deciding who to trust?
As for me, I found out that as the scientists were not up to date in their information, so I couldn't actually trust anyone. That's how I was now confused. Who do I believe? What do I do? I felt that there was no proper investigation. There was no proper investigation, and they didn't come as a group to confirm actually this is what should be done. We were speaking on individual basis, and it was not from a scientific point of view, scientific backing. So I was actually confused and wondering, they should have come up as a team to speak up on what was right.
And for a while, people didn't know what was right. You know, they were basing their recommendations on previous viruses and the way they transmitted. And this ended up being completely new, which they didn't know. Brenda, what about you? Are you there? Brenda?
Yes, Doc, I'm here. I actually agree with Gloria. I didn't believe the scientists, and actually, it was so confusing because we were hearing so many theories from different angles. So we end up being confused, like what exactly is this COVID and how really should we deal with it? Because as for our generation, like you said, it was our first pandemic. Like we're hearing theories from the past, like the influenza. So it was really confusing, and I personally didn't trust any of the theories that were being said.
Okay. Caldrian, what was your experience?
Um, Essentially, any news, kind of in relation to what you do, what you should do, any vaccines you should take, precautions you should take. I think the general population was just, well, I believe the general population was just taking whatever they were hearing on the news and just running with it because you really didn't have anything else to go off of at that point. And since there was so much mass hysteria about what the pandemic was and what COVID could do or what it could not do, I think, well, I'll speak for me specifically. Whatever I was told, or suggested, I would pretty much do.
Okay. Shepard?
Yes, Prof. For us Africans, we thought they are experimenting on us on those drugs. It was not clear to us as Africans. So we ended up taking our own local medicine.
Yeah, very different experience, right? Mungo, what about by you? Are you there?
Hello?
Yeah, I can hear you.
Yes, yes, Prof. I'm saying to us Africans, it was not clear because we were not sure whether they are experimenting on us on those drugs because even some Africans, they were dying after taking those drugs. So for us, it wasn't clear.
Right. And see, that's one of the horrible things whenever science is misused in unethical ways, because we've had that in the US as well, where African Americans were experimented on without their knowledge. It totally destroys trust. It totally breaks down the system of, can you trust the expert? Can you trust the doctors? It's really difficult to try and to filter through. Especially when they don't really know the answer, right? Anybody else want to say anything on that? So the folks that haven't taken this course, they're going to be in the same position on climate change in that, which experts do I believe? Somebody, I've heard it spread around the internet saying that, scientists keep perpetrating this hoax about climate change because they'll get more money. That's how they get money, which is kind of a ridiculous claim. But for folks who don't know how science works, they might believe that. I mean, when I apply for funding for my research, I might get supplies for my research and money to hire a graduate student, but I personally don't get any money for it. It doesn't increase my salary or anything like that. So it's not really a motivation for science. And it's this really interesting effect when you look at people who don't know anything about it. And this is a reason why I think in general, you're more better off if you trust experts, even if what they tell you initially is wrong, because at least they know a bunch about the science to begin with. Now, what arises might be very new and they could be wrong, but they probably have a higher probability of saying the right thing than people that don't know anything about the topic. And there's actually the study that was done by Dunning and Kruger, and they discovered what's called the Dunning and Kruger effect. And they actually made these measurements. They polled a lot of people, and it looked at confidence levels in statements versus knowledge. And what they found was that the people that were most confident about what they were saying had absolutely no knowledge of the field. Those are the most confident people, are those who have no knowledge. Basically, they don't know what they don't know. They just think, oh, you know, this is the way it is. And they're very, very confident. Now, as your knowledge increases, it turns out the confidence starts to drop. And this little point here, I like to use this when I talk about graduate school. So when you're going for your PhD, this little low point over here is usually equivalent to probably a third-year graduate student, where they're at the point where they realize there's so much stuff that they don't understand yet and they don't know, and it's overwhelming, and they're like, I don't even know if I should be in this field anymore because, oh my God, I'm not, there's so much stuff. But as time goes on and they learn more, then their confidence starts to increase. I've been doing this for about 20 years. And so I've got pretty good confidence level in the science that I talk about that's in my field, but it nowhere near comes close to the confidence those people feel that know nothing about it. Because at least I still know what I don't know. There's a lot of things about climate science that scientists don't know yet. You know, a lot of big questions out there, stuff about, you know, what's going to happen with the permafrost and about different feedback loops and the extent of them, whether they're positive or negative in some cases. And so there's a lot of stuff that we don't know. And then there's a lot of fields, you know, atmospheric chemistry, I know some, but there's a lot that I don't know about the field. And so my confidence level in anything I state is going to be a little bit adjudicated by the fact that I know I don't know much. But those people who are the most confident, beware of them. You've met many of them. I'm sure you have somebody in your family that's that way, that's totally confident, and you know they don't know anything, right? But it's interesting that this was a really good thing. And the one last thing that I'll throw on there is I did want to mention, you know, if you look at the same effect with vaccines, there's a lot of people who are saying, oh, I'm not going to take the vaccine. It's deadly. It could kill me and stuff. And so I wanted to look at, just go over a little bit with vaccination stats. So in the US, we've had about 200 million vaccinations, and we have no deaths that are attributed to those vaccinations. There are a couple close calls with some allergic reactions, but no deaths. Now, let's just say, for argument's sake, that 10 people died. So that would basically be 1 in 20 million people dying from these vaccines. Okay. 1 in 20 million chance. What's that like? Well, if you were to get in a car in the US and drive 5 miles, you'd have about a 1 in 20 million chance of dying in a car accident. But people drive every day. It's a simple, you know, we don't even think about it. It's not a risk to us. Doing an hour of snowboarding or water skiing, 1 in 20 million chance of dying. Yet we do that without even thinking about it, you know, thinking the risk is really, really low. Now, if you look at the bad outcomes in the US, the chance of death from COVID is about 1 in 550. Now, you're all young, so you're probably a lot more resistant to the virus and probably won't die. So let's say your chance of dying is 1,000 times lower. So that's 1 in 550,000 chance of death. But that's a way higher chance of dying than 1 in 20 million. You know, and even if you don't die, You could have post-COVID problems like the loss of smell, the loss of cognitive function. You know, and so those people that are making those decisions to not get vaccinated because of the risks are making the wrong scientific bet, if you will. So message from that is, if you haven't already, get vaccinated. It's been several years. I've had the vaccine and the boosters and that, you know, several times. And I'm still alive and kicking, and I don't immediately feel a need to do whatever Bill Gates says has been promoted on the internet. But I'll kind of leave it there. And then on Friday, we'll go ahead and start getting into the climate science. Now that at least we know where our facts are coming from. And, you know, now when facts come up, we know the best way to question them, which is, okay, where's the peer-reviewed article? Where's the actual stuff that you're saying that shows that it's a peer-reviewed article that hasn't been dispelled? Any comments before we break?
Thank you, Doc, for the lecture. I wanted to request if you could send us the recording of the lecture. Like the previous lecture, I didn't hear much. There was a lot of network breakdown.
Oh, okay. Yes, I will. I posted it up on Moodle, but I will find the link to it and send it to you directly.
Okay, thank
Probably,
you.
I got 2 classes I got to teach, but I can do it right after that.
Okay, thank you.
Okay.
Thank you so much, everyone. Have a great
Yes.
day. Okay, bye-bye.
Thank you, Prof.
Thank you, Prof.
Thank you.